Today's question is merge intervals. Given an array of intervals where interval I will have start I and end I, merge all the overlapping intervals and return all array of the non-overlapping intervals that cover all the intervals or in the input. So it's basically trying to tell us that we'll have a intervals series of intervals, and we are basically trying to identify the overlapping intervals and merge them together. So obviously you can clearly understand from here that it's 1 and 3 and 2 and 6 are the potential overlapping intervals which has got merged to 1 and 6. For the better understanding, let's just go into the whiteboard and see how we say that 1 and 3 and 2 and 6 are overlapping with each other. So this is the start point and this is the end point. It's like uh, boy A was running from the point A to B, and he did not, or maybe 1 to 3. Okay, he's running, he has one checkpoint as to, at maybe 1 kilometer and the another at 3 kilometer. He was running but he has not completed, but the boy B started to run in between. So that is when we say that it is overlapping. So in short, this has to end before this has to start. This will start, then only this will start, then only we can say it's non-overlapping. That's the fair comparison between the end and the start point, right? So the comparison should work in such a way that it has to have some comparison between the end and the start. Since I'm saying the comparison should be for the immediate end to the initial start, we need to have our series in a sorted order so that we can do this comparison, and it will finally give us a desired answer. So for that, the very first thing is sorting. Once we have sorted, we'll be sorting as per the starting point. So 1, then 2, then only 8, and then finally 15. So this would be the fashion. Once we are done with that, the comparison what we are looking for, the end point and the start point comparison, we will be doing it. So we'll have the start as the 1, this, and end would be this. Okay, so let's run through the code. So what we are planning to do here is that once we have sorted and once we have fixed our start and end, we are going to loop. We will be looping through the we'll be basically iterating the all the intervals. So once we have a, so okay, if I is 0, then I of 0 will be what? It's basically 1, and I of I of 1 is going to be basically 3, right? So this is the fair thing from this particular interval. Every time whenever I am dealing with this kind of situation, I always have to remember that I am going to deal with my previous interval, right? When I am dealing with 2 and 6, I need to remember the interval of the previous end point of the previous interval. So for that, what I'm going to do is the fair comparison would be, first comparison will be, hey, if these guys, okay, so what is my start? The start is S1, end is 3. Just remember these points, because this is the ultimate point which says that right now I am at this point of time and I am here. Okay, start and end is here. However, this I0 and I1 will be changing. So at this point of time, I0 and I1 is this. In second iteration, I0 and I1 will be in this. Third iteration, I0 and I1 will be here. And fourth iteration, I0 and I1 will be here. But start and end is finally going to give us the result which we are looking for. Alright, so what we are going to do here is we will be comparing whom to whom. I0, the start of the so this is start of this particular interval. So the start of the interval of what we are running with, the end of the interval. Okay, so the start of the interval, if it is greater than the end of the interval which we have right now so far, if that is the case, then we will be pushing the value. Okay, but in our case this is not the condition, right? So if I say that 1 is, so this is basically holding false. Since it is holding false, we will be updating our end. So E is going to get the maximum of whatever it has, which is E itself, and what it has in this particular iteration as an endpoint, because it is also endpoint for this for this interval. So I of 1. Okay, so with this combination, what do we have in our E? It is 3 itself. So far we have done no changes. S we never changed, and E itself is 3. So pointer at the same place wherever it was earlier. In the second iteration, things will go interesting. Now in a second iteration, I with 0. Okay, I with 0. I with 0 is what for the second iteration? It's 2. That's the start point for the interval 1. And I of 1 is going to be what? 6. And that's the end of the interval 1, right? So the start and the end is been collected for the particular interval, but the comparison will be with the start of this but the end of previous what we had, because that is when we know that 2 has to be compared with 3, not 6. So we know we have an account of that. So if in this condition also I of 0 will be compared with whom? The end. End is 3 itself. This condition is false, and that is when we will update our E with whatever maximum we can get from E, whatever we have, and the running end. So in this case the end gets updated to 6. This is going to give us 6. So from here the end gets, or let's just from here the end moved here. Now the new end is here, and this got cancelled. So here is the starting and here is the end. Still we have not pushed anything in our code. Then comes I equals to 2. When I is 2, okay, so the iteration will run. I of 0 is going to be, I of 0 will be what? So this is 2. So I of 0 is 8. I of 1 is what? It is 10. Okay, and now the condition is, hey, whether my current intervals start, which is I0, is it greater than the previous intervals end, which is held by E, which is 6 for us? It is true for this, because I0 is 8 and current end is, previous end is 6. So this condition is true. If the condition is true, what we're going to do is we'll have this pair of start. Don't forget this start is still at here. So the start and whatever end we have come up with is going to get sorry for that. So this is going to get pushed in our result value. It is going to get pushed. So this is collected in our RES. Okay, it has this. Now since we have already dealt with the starting point and the ending point, now it's a good time to update the start and the end for the further comparison. So now start is going to be the these two values will be the start and the end. So I of 0 is going to be the start and end is going to be I of 1. So that's that will be the orientation once this if condition is true. So if condition is true, we'll collect the starting and the end so far what we have iterated, and then we will be changing the start and the end. So that's all for ith value. Now second value, now I goes to 3. I of 0 becomes 15, and I of 1 becomes 18. Alright, and now at this point of time what we're going to do, we'll just first check that if condition holds true or not. So I of 0 is going to get compared with the end. So I of 0 is what? 15. End is what? I of 1. I of 1 means 10. So 15 is, yes, it is greater than 10. So now that basically means, okay, let me just write it here. My new start is 8 and my new end is 10. So the comparison holds true, and we are going to do the same job. RES will have the another pair of start comma end, which is 8 comma 10, and so here start had 1 comma 6 Okay, this is one entry, this will be another entry which is itself 8 comma 10. When non-overlap or overlapping situation comes, then this happens in one go itself. If condition gets true and you're pushing the validated pair, now the start will get updated again, I of 0 and I of 1. So this helps us to get the value I of 0 as 15, and the end gets updated to I of 1. So that itself is 18. Alright, and this is done. Now the last iteration, because we only have 4 intervals with us. So with this, okay, now where are we? So initially start was here. Once this got pushed, our start got shifted here, right? These were the places where our start and end were. This was start and this was end. This got cancelled and this got cancelled. Once this is done, then we shift it to this place. So now this is also cancelled, and now our start is here and end is here. So this is end and this is start. Alright, so right now we are with our last, because this is 0, this is 1, this is 2, and this is 3. So we worked with 0, we worked with 1, we worked with 2, and we worked with 3. We worked with 3. So what is happening? Okay, so sorry, I equals to 4 iterations is not there. So once we are done in our res, we are done with the iteration because we only have 4 intervals. So res already has 1 and 6, it has 1 and 6, it has 8 and 10 as we saw right now, but it is missing one interval, which is 15 and 18. So right after the for loop, we can just write a last, because start and end has a valid entries, and we know it's a last entry, so overlap, no chance of overlapping with anything, so we can simply push that. So this start and end will be pushed here. So outside the loop will push res equals to s comma e, so which is basically 15 comma 18. So that's the whole idea. So it's outside the loop, all right. Now once it is done, res will have this 15 and 18, which we did not collect it within the loop, but then outside the loop on just one single line, and we are good. So these 3 are the valid answers. So that is how the algorithm will work. We'll sort it, we'll set the start and the end, and then we will run the loop for the entire interval in such a way that for when we are dealing with the next interval, we'll have a record of the previous end of the interval. And that is when we started with I equals to 0, and then for the comparison, the only agenda for starting from I equals to 0 was to hold the end value. The condition will be false and end value will be pointing to the 3 and 4, so that the next time when we are iterating, then we will compare with 2 to 3, then 8 to 6, so on and so forth. Okay, let's start and code the solution. So the vector, so it's vector of the integer type will be the res, because that's the return type of the given function. All right, and we'll have this int start, which is basically intervals of 0 and 1. Then comes end, which is intervals 0 and this is 0, sorry for that, and this is 1. So that's the initial starting points. So what did we just say? That before this, what we are going to do, we will be actually sort the intervals begin and till intervals end. So we'll first sort this. Once we sorted, once we are done with the sorting, we will then initialize our start and the end for the comparison. Now it is a good time, so I'm going step by step. First we have sorted, second we have set marked our start and the end, and then we are now going to iterate. So for auto, I is going through the intervals. Now for the interval iteration, what we are going to do is we have base condition I of, not base condition but if condition I of 0 if this is greater than the end. So we are good for pushing we are good for okay, yep. No, so if this condition is true, we are good for pushing the element in our res. So res, sorry for that, res can push this start and the end, because the I0 value is greater than the end value. So in this condition, S and E is going to get, so it's start for start, start, and end is going to get pushed into our pushback function. It's pushback actually. So yep, that's all. And as we said, we are going to start I with 0 and end with I of 1. So that is the another important thing which we are going to do. So it's pretty much same what we have discussed. Whenever the condition is this, then we are pushing the element and we're updating the start and end. So we pushed the element and we updated the start and the end for whatever we are running for. But if it's not the case, which in that condition we are going to basically update the end so that we'll have a track of the end of the previous interval, getting the max of end and the iteration end, intervals end. So that's the whole idea of for loop. It will run till 0, 1, 2, 3 in this condition, and just right side after coming from the loop, we can push back the last start and the end, because we have seen we missed the last potential pair if we are done with the iteration. Right now we have seen, so we have written explicitly that right after coming from the loop, we are going to push the start and the end, so that by the end of the entire function call, we'll have all the intervals. So let's run it. If it works well, then I'm gonna go ahead with okay, typo, it's a vector, then I'll recap it. Okay, there is a okay, sorry, I did not return anything. Actually I have to return res, and that is why I have created this vector. So vector of vector. Alright, so it got accepted. I hope all the test cases ran, just to be extra sure. Alright, so let's try to submit it. Alright, it got submitted. So since it is since it has got accepted, let's just try to recap it before ending the video. So what we have done is we got the intervals, we got the range of intervals. Okay, this is the range of the intervals. Range as in like the different varieties of intervals we'll be getting. The very first thing which we are going to do is sort, because the idea what we are running on will be only good when the element when all the intervals will be sorted. So the first thing is sorting has been done, then we'll be setting the start and the end. This is going to be basically is the entry for the result array. Result array will only have the start and the end. I0 and I1 will help us to update the start and end. Then we'll be iterating through the intervals, and once we are iterating to the interval, whenever we see the potential situation where the things are not getting overlapped, which we just explicitly saw here, that hey, when the starting and the ending has a relationship where the start is greater than the end, like 8 is greater than 6, 15 is greater than 10. So if this is the situation when the start is greater than the end, we'll push it and we'll update the start and the end. But if that is not the condition, then we'll be updating the end. only. And why the extra this outside the for loop? If you actually if you have followed this entire dry run of the algorithm, you have explicitly saw here that we were only able to push 1 and 6 and 8 and 10. We missed 15 and 18. So for including that, we had to write it we had to write a last single line where we are pushing this right after the loop, because we have to include all the intervals without missing any. So that is and then finally returning res, because the return type was vector of vector ins, and that is why we have created this res as a result vector. So yeah, that is pretty much for the merge interval. Thank you very much.